We have even, odd, and neither functions. Okay. What makes a function even is that in its most basic form, it has an even exponent, like x squared or x to the fourth. An odd function has an odd exponent, like x cubed, x to the fifth, x to the seventh. And a neither function is none of those, none of the above. And the only one you need to know as of now is root x. Okay? Now, each of these functions have 3 key points that you need to know. These are the basic form of the functions. So you need to know their basic key points before transformations happen. Okay, so the key points of x squared are -1, 1, 0, 0, and 1, 1. All right, that makes sense because if I were to graph an even function like x squared, what does x squared look like? It looks like a u at the points -1, 1, 0, 0, 1, 1. That's how it starts off with. But then once I start shifting it around, this is my go-to before I even apply that math, okay? To know how these points shift. And these functions are also symmetric to y-axis. So notice if I take one of these quadrants and flip it over, I get the exact same thing on the other side. Hot dog style. Symmetric to y-axis, you can think of hot dog. It's flipping over the y-axis long ways. Okay, now with odd functions, very similar, but instead of -1, 1, we have -1, -1. We still have 0, 0, we have 1, 1. All right, and these are symmetric to the origin. So this is, I'm going to put hot dog, and this is hot dog, hamburger. So you have to flip it over the y-axis and the x-axis. So -1, -1 is here, 0, 0, 1, 1. We still have those two. Okay, that's the only difference. Instead of here, I have it here. All right, and this is an S shape. And again, it's symmetric to the origin because if I take one of the quadrants, I have to flip it over the y-axis and the x-axis. So if I flip it over the y-axis, it'd be here. And then if I flip that over the x-axis, we get that. So it's y and x. Symmetric. That's called symmetric to the origin. And then the neither graph, okay, the points that we start off with before transformation is 0, 0, 1, 1, and 4, 2. Okay, and this is not symmetric to the y-axis, and this is not symmetric to the origin. This graph just looks like this. 0, 0, 1, 1, 4, 2. Just looks like that. Okay. Again, you don't. This is on your cheat sheet. What points it starts off with is very important. These are our key points. Okay. And then when we apply the transformations, it applies the same for all of these. Okay. Make sense? So what I would do also is that wherever I see an x, I put parentheses around the x. Okay, because you'll see that some math applies inside the parentheses and some math applies outside the parentheses. So now moving on to the actual transformation. This just tells us, again, even, odd, or neither tells me what points I start off with. Oh, one last thing. Even functions, one that we treat as an even function is f of x equal to absolute value x. So let me erase this so that they're together. So we have f of x equal to x squared. But we also have f of x equal to absolute value x. The reason they both use these same points, they're both even functions. And the reason for that is, again, if I were to graph this absolute value function, I have the points -1, 1, 0, 0, and 1, 1. But instead of a u, I have a v. Right? This is important. Notice I'm still symmetric to the y-axis. That's why this is still an even function. So if I see a function with absolute value sign, again, it doesn't have to have an exponent, no exponent. But if I see a function with an absolute value sign, I treat it as an even function. Because it's the same graph, essentially. It has the same 3 key points. It's symmetric to the y-axis, and the transformations apply the same to this function. Okay, there's just no even exponent. We just have to remember absolute value is an even function. So now, this is essentially what the transformations is. We have math happening inside parentheses, and we have math happening outside parentheses. Anything inside is horizontal. So that just means that it affects my x. And then for this guy, I have to think opposite. Can you guys see that? Yeah, think opposite. Outside parentheses is vertical. That just means it affects my y. My y value. And I don't have to think opposite. The only one I have to think opposite for is my horizontal. All right, so keep that in mind as we're applying the transformations. So, one example, let's say I have f of x is equal to x squared plus 2. What would be the most basic form? What is causing a transformation? What's causing a transformation is that plus 2. Without that plus 2, I have a basic function. With that plus 2, it complicates it. It adds a transformation. So again, I go, what kind of function is this? Oh, I have an even function. So I use even points, even key points. What are my even key points? X, y, negative 1, 1, 0, 0, 1, 1. Okay, now I have to determine, is this plus 2 happening within parentheses? So inside parentheses, is it bounded by parentheses or outside? I don't see any parentheses, so that means it's happening on the outside. So I have this. I have something vertical. And now I have to acknowledge, what is it affecting? If it's vertical, does it affect my x or my y? Does it affect my x or my y? Outside parentheses, vertical, affects my y. So that means if I look at my key points, my x's are going to stay the same. Negative 1, 0, 1. But my y's are going to change. How do they change? Well, if this is plus 2, that means to my y, I'm also adding 2. And what is this doing? Vertical, I would also think in terms of the shifts up and down, and horizontal is left to right. All right, so if it says plus 2, what would you think? It's moving my graph up or is it moving my graph down? I'm gonna move it up. All right, pretty straightforward. So what are my initial y values? 1, 0, 1. And I'm affecting my y because I'm adding 2 to only my y. So now, with the transformation, what is my new graph? My new graph is negative 1, 0, 1. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. These are my new points with the whole y plus 2 transformation. So this is my new function. So this is just saying that these are points on my graph of this transformation. These are not points on my graph. I'm just taking these points and applying the transformation so that I actually get points on my graph. So I'll graph these on the same line. Let me just erase this. And we saw how we got there. All right, but now let me actually graph this. So I'll graph this one in black and that one in blue. This one is 0, 0, negative 1, 1, 1, 1. That blue guy is -1, 3. So -1, 1, 2, 3. 0, 2, 0, 1, 2, and 1, 3. 1, 1, 2, 3. So now this is my new graph. You can see the shift up 2 from each of these points. Okay? If I were to put -2, I would take my y and subtract 2, and -2 would mean I move my graph 1, 2, down 2. Okay? Now, let's do a horizontal example. That's what I want to graph. Okay, what would be the most basic form of that function? I see an even exponent. So that means that I have an even function. And what are the key points to an even function? -1, 1, 0, 0, 1, 1. So those are the points I'm going to start off with so that I know what this graph looks like. Right now, I don't know what it looks like. Okay? So now, what is causing the transformation? That -2. That -2 is making this not look like the basic. The basic looks like what? F of x equals x squared. So that -2 is what's causing the transformation. So now I have to analyze, is this inside or outside parentheses? It's happening inside parentheses. Next to the x inside, I see parentheses, it's happening inside. So what does that mean? I have a vertical or horizontal shift. This time I have a horizontal shift. Anything inside parentheses is horizontal. So what does this mean now? Is it affecting my x or my y? Horizontal only affects my x. So my y is going to stay the same. However, my x, I'm going to do some math too. What math am I doing? So one thing I wrote here that's important is with horizontal, I have to think opposite. And horizontal moves my graph left to right. So you would think naturally that that -2, since my horizontal moves my graph left to right, that -2 would mean it moves to the left too. That's wrong. I have to think opposite. So that -2 actually means that I'm moving my graph to the right. Okay, so opposite. So because I'm moving my graph to the right, 2, I'm going to add 2 to my x. Okay, so the opposite. X -2 actually means add 2 to your x. And x only. Again, what was my initial x values? -1, 0, and 1. Now, what is the result? After doing the math, what is the result? -1 plus 2. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And I still have 1, 0, 1. Okay? Now I'm going to graph it. I'll graph both of them again at the same time so you could see how my graph moves to the right. Just a little bit. Right, 0, 0, -1, 1, 1, 1, u. Now I have 1, 1, so I'm going to overlap that guy. 2, 0 should be there, and 3, 1 should be there. Notice each point moves 1, 2, 1, 2, and 1, 2 to the right. Okay, so with horizontal, we have to think the opposite. So that -2 actually means add 2 to my x. If I were to say x plus 2, then I would subtract 2 to my x, and that would mean that I move to the left. Okay, so -2 actually means I move to the right, but +2 would mean I move to the left too. Again, inside parentheses, reflection. This is going to be reflection over y-axis. Outside parentheses is going to be reflection over x-axis. Okay? You kind of, and I'm going to eliminate this because now we're talking about reflection. So we're not talking about shifts up and down and left and right. We're talking is flipping the graph. So these two are referring to flips. And it's the same idea, all right? Inside and outside, and what you're worried about is the multiplication of a -1. Okay, so is that negative on the outside like this, or is that negative on the inside like this? Okay, so an example of this would be f of x is equal to the negative. Okay, is this inside or outside my parentheses? Outside. Okay, so what does that mean? Well, first of all, to have an even or odd function, I see an even exponent, so I have an even key points, -1, 1, 0, 0, 1, 1. And this is the graph f of x equals x squared before transformation occurs. Now, what is the transformation? Is this happening inside or outside my parentheses? Is that multiplication of a -1 happening inside or outside parentheses? It's happening outside parentheses. So transformation is this. Oh, I don't want that. Transformation is this outside parentheses. So what does that mean? If it's happening outside, it's affecting my y. So my x's are going to stay the same. What are my x's? -1, 0, and 1. But my y's, what am I doing to my y's? The same thing that it's doing to my function. It's multiplying by -1. So I'm going to multiply my y by a negative. So now I have negative, 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 whatever my y is. -1, -0, -1. These are my original points that I'm multiplying by a negative. What is the result? My result is x's stay the same. -1, 0, and 1. But now I have a negative y. So I have -1, -0 is just 0, and -1 again. Let's graph both of these on the same graph. Zero, zero, -1, 1, 1, 1. You guys are going to see the reflection over what? This is happening outside my parentheses. Outside means reflection over the x-axis. So I have -1, 1, 0, 0, and 1, -1. We see that flip. We see that the hamburger flip down over the x-axis. Okay? So now, quickly, if I had a reflection inside parentheses, I wouldn't see this reflection. What would I see? Well, this one's not a good example because this is an even function, right? Which means it's symmetric to my y-axis already. So if I flip this quadrant on this side, I get the same thing as I flip it over this side. It's already symmetric to the y-axis, so this is not really going to do anything to my function. And that actually makes sense because what's x squared? It's just x squared. It's my original function, which is why my function is even. All right, but I'll just prove it to you. Prove it to you quickly. Again, this is my transformation. This is happening inside parentheses. So that means it affects what? Inside parentheses affects my x. So to each x value, I'm multiplying by a negative. My y's are going to stay the same, 1, 0, 1. What are my x values? -1, 0, and 1. Those are my original x values that I'm multiplying by a negative because I have it inside parentheses. So negative times a -1 is just 1. -0 is just 0. And negative times 1 is -1. Notice I have the same points. -1, 1 is up here. 0, 0 is up here. 1, 1 is up here. Okay, that's why I still have the same graph. They just overlap. Okay, which is proving that it's symmetric to my y-axis, but also it's important to note that that's still to, like, let's say odd functions or different types of functions, this will cause a reflection over the y-axis. Okay, so we went over horizontal shift, vertical shift, and reflection. The importance is understanding whether this is happening inside or outside. Anything happening inside is going to affect my x-axis. And I have to think the opposite when I'm adding, subtracting. And anything happening outside is a vertical, and it's going to affect my y. So whatever math, so if it says +2 outside parentheses, that means y +2. If it says x +2 inside parentheses, that means x -2 when I apply the math. Okay? This is what I want to graph. What is my original function? What would be the basic form of this function? I have 2, which is even, so I have an even function. So really, I start off with these points of x squared, which is -1, which is -1, 1, 0, 0, 1, 1. Okay, now I need to apply the transformations. How many transformations do I have? I have 1, I have 2, and I have 3. Okay, I think I'll color code each of these so you don't get confused. This negative transformation is going to be negative, so it's a reflection. I just don't have to determine if it's reflection over my y or reflection over my x. That -3 I'm drawing pink is that. And then finally that +2, what is that? All right, there's an order of transformations that we must go through when we analyze, okay? So it goes horizontal first, we look for that, anything inside parentheses. Then second, we look for shrink or stretch, but we're not going to worry about that right now. So it's horizontal shift, then reflection, so any negative, like this case. Finally, vertical shift, okay? So now, let's go through the list. Again, that's on your cheat sheet. Let's go through the list. So I have x, y, but I'm going to leave some space now because I don't know what I'm doing to my x. So I'm just writing them down in the middle, and I'm going to put my x and my y in parentheses so I stay organized. All I did was rewrite this, okay? Put it in parentheses so you guys can see the transformation. So the first thing I look out for is a horizontal shift. Do I have anything happening inside parentheses? Yes, this is the only case right here. What's it saying? -3. Okay, it's inside parentheses. It's horizontal. That means it affects my x, and ooh, I have to think positive. I have to think opposite. -3 means right 3. The opposite. Okay? So because it's doing the opposite of what I would naturally assume, okay, that -3 means right 3, I'm actually adding 3 to all my x's. As so. That -3 means +3 to all my x's. So that's the first thing I look for. The second thing I look for is reflection. We're skipping the shrink and stretch. The second thing we look for is reflection. So what is this saying? Is it inside or outside my parentheses? Okay, this time it's outside my parentheses. I have this scenario. So I have reflection over my x-axis. So what does that mean? It's vertical, so it's going to affect my y. So just like I see a negative times, I'm going to multiply all my y by a negative. So this is going to cause reflection over what? Over x-axis. Now, the final thing I look out for is a vertical shift. Again, addition and subtraction happening outside parentheses. So again, I have a case of something outside. It's vertical, so it affects my y. Because it's vertical, I don't have to think opposite. So that +2 literally means +2 to my y. Okay, so I can do all these shifts all at once if I want to. Now I'm just going to write down the summation of everything. Okay. So x plus 3, -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. Done with my x's. -1. Negative times 1 is -1 plus 2 is 1. -1 plus 2. Oh, you know what I did? Silly me. This is supposed to be 0. 1, 0, 1. Sorry. Like when I rewrote the problem, I didn't write the problem exactly. Okay? So -1 plus 2 is 1. -0, 0 plus 2 is 2. And -1 plus 2 is 1. All right, so this is my new graph. I'm going to erase this guy. Okay. And let's see how I should do this. What I want to do first is graph the original one, which was 0, 0, -1, 1, and 1, 1. And go step by step and then show you guys how the result here is what matches. Okay, so what was the first thing? My graph moves, oh wait, not graph, but up to. My graph moves to the right 3. 2, 3, 4. 2, 3, 4. Okay. This is going to have 1, 2, 3. Since I'm moving my graph to the right, this is going to have 1, 2, 3. Again, moving my graph to the right. 1, 2, 3. Moving my graph to the right. Now I'm going to erase the hops just to show what it looks like now that I've shifted it to the right first. I just moved it to the right 3. I picked this graph up, moved it to the right 3. Now, green saying to take this graph and do what? Reflect it over. So 0, 0 is still there. But reflecting this graph over is going to move this point over here, same distance from 0. This. That's what reflection does. After the horizontal shift, reflection flips it over. Finally, up 2. Each of these points, this -1 point is going to move up to 1. This point is going to move up to 2. Up to 1, 2. 1, 2. This point is going to move up 2 also. And it's still going to face down. That didn't change, it didn't reflect back. Okay, now let's see. Does that make sense? My final graph should have 2, 1, 1, 2, 1, which it does. 3, 2, 2, 3, 1, 2, 3, 1, 2, yes. And 4, 1. 1, 2, 3, 4, 1. Which is why this is my ultimate graph. So that blue graph, the graph in blue is my final results. So all I did was break down the steps, but it shows you how we got from here to here. The horizontal shift first, the reflection after, then the moving up 2. That's how I got my final result. I could have just gone from the black to the blue, but I was just showing you guys a breakdown in the order of transformations that we go in. Okay? So now, quick question. Let's say I had this. I want you to graph that. Okay, what I want you to understand is that the transformations are the same. This is still going to move my graph to the right. This is still going to reflect my graph over the x-axis. This is still going to move my graph up 2. And this is still going to be my resultant point. Why? Because anything absolute value, what is the basic form of this function? F of x is equal to absolute value x. Correct? So, what are the key points of an absolute value function? Again, we treat it like an even function. So it has the same points as an even function, -1, 1, 0, 0, 1, 1. Isn't that what we had initially when we had it with parentheses squared? Yeah, we still have an even function. So I still have these points. So that means my results should be the same. But instead of having a u downwards, what are we going to have? We're going to have a v downwards, but still connecting at these points. The exact same graph, just instead of a u, I have a v. The transformations apply the same. All right, just going off of the transformation videos, I wanted to offer some more examples, but just to reiterate, again, we have even, odd, and either functions. What this is saying is that you start off with 3 key points. So if you have an even function, an even exponent, you start off with these points before transformation, so in the most basic form of the function, so without any of the +3, the multiply, divide by negative, or -2, any of those horizontal, vertical, any of those transformations, you start off with these points. Then we can apply the transformations by analyzing if the transformation is happening inside or outside the parentheses. So it's going to apply the same to odd, except I start with these points. It's going to apply the same to neither, except I start with these points. What do we treat like an even function? Absolute value. Okay? Again, like I was saying, we determine the transformations if it happens inside or outside parentheses, but if we have absolute value, it's inside and outside the absolute value signs. If we have a square root, it's inside and outside the square root. Okay? So not always parentheses, but you can think of it like parentheses. Absolute value sign, square root, but the transformations are identical. The same. Okay, so let me just offer some practice problems, especially with the square root x, since we didn't really touch upon examples of that. We just talked about the transformations, but they apply to all of them, and you'll see that this should clarify that concept. Number 6 is shifted to the right 3 units. So if I'm thinking left and right, I'm thinking horizontal. So I have to think opposite. So if it's shifting to the right 3 units, that actually means x minus 3 cubed. So again, in the homework, we did a lot of practice with even functions, so that x squared, and I explained absolute value. But as you can see, again, this is an odd function, and the transformation applies the same. Where right 3 is actually x minus 3 in parentheses, exactly the same. Okay. So I see a square, so I see an even function. That means I have a U. Going through the steps, first I look for a horizontal shift. That -1 means to the right one. So I move my graph to the right. Then I look for a shrink or stretch. Again, don't worry about that. Then I look for reflection. Okay, I have a negative being multiplied. Is it being multiplied inside parentheses or outside? Negative outside means it affects my y. So it's like a vertical kind of thing. And what that does is it reflects it over the x-axis. So it's going to flip this down. So I'm going to mirror it down as so. And then finally, I look for a vertical shift. That +3 literally means +3. I don't have to think opposite. It's vertical. I don't have to think opposite. And that's it. Let's see. We got the right answer. Okay, so aside from the transformations, you will need to know how to read two graphs. Okay, so one of the practice problems I gave you guys in class from the packet is something like this. So this would be practice problem number 10. Let me see number 9. Yeah, number 9 is just the transformations that we just went over. Number 10 would look something like this, where they give you a graph and you have to answer a set of questions for that graph. So one thing I'm looking out for is domain. Again, how do I read domain of a graph? I look at it left to right. I just scan the graph left to right. So what is my left? And I'm looking at the x-axis and where my outputs are. I'm not following the graph like this. I'm looking, I'm just looking at it from left to right, and imagine like having a sheet of paper and just scanning the graph. Right now with my little scroller, you can't really tell, but just scanning the graph left to right. Okay, so aside from the transformations, you will need to know how to analyze two graphs. Okay, so problem 9 was the transformation problems. That's what we just went over. Problem 10 would be something where I give you a graph and you have to answer a set of questions, such as domain, range, x-intercepts, y-intercepts. Is there symmetry, even, odd, or neither? Yes or no. And intervals, where it might be increasing, decreasing. And aside from this, also when my output is above or below the x-axis. Okay, and I think this one does a better job of it. Okay, so this is my graph. Imagine I have a sheet of paper and I'm just scanning the graph from left to right. That would be answering my domain problem. What is my leftmost value? Okay, so again, domain is talking about my x values. Okay, so where does my graph start? It starts here, right? But I'm not looking at the y. Where am I looking at? My x domain, and I'm scanning left to right. So at this y point, which is y is 3.5-ish, what is my x? My x is, it appears to be right in between -4 and -2. My x is -3. Okay, that's where my graph starts. Left to right, domain. Again, I'm talking about domain. So I'm looking at my x value. It starts at x equals -3, and where does it end? Scanning left to right. What is my rightmost value? Oh, I have an arrow. Can I bound an arrow? I cannot. So what is my leftmost value? Well, if that arrow is continuing on forever, that means this graph is going on forever and ever and ever and ever as I go towards positive infinity. So that is how I write my domain. I have a point at -3. So that is close bracket. And it goes towards infinity. Makes sense? Here, let me take a screenshot of this image. Sorry, it's lagging a little bit. What I'll do is just so I'm able to annotate over the picture. Let me see. Because I think it's
Domain and range will be easier to understand if I'm able to annotate the image. How do I upload an image? Images, upload image. I know, a bunch of screenshots. Well, that's how I make the packets. Okay. Now, there's my image. Now I want to draw over this image. I'm pretty sure I can. Okay. So again, domain I scan left to right. So what I would do is, oh, wow. Not the best drawing. Okay. Sorry. Let's try that again. Domain. Remember, it's like I do a dashed line at my leftmost value, and then I look at my X value at that value. So we already established that my X value is -3. And where does it end? Again, left to right. Looking for the domain. Can I put a bound on something that has an arrow? No, this is going past that line. This one I can. It's like a bound right there. So for sure, it's at -3, and there's a closed dot at that point. That's why I'm writing bracket. Okay, closed dot. That means I have a point that is inclusive. Bracket. -3. Where does it stop? I don't know because I have an arrow. I can't really stop it with a line. So that means it's going towards positive infinity. Whenever I write infinity, I write parentheses. So that would be my domain. Left to right. This is my leftmost value. Again, I look at my X, not my Y. I have a closed circle, so bracket, and it's going towards infinity because I have an arrow, and I can't bound an arrow with a line. So that is my domain, -3, 2, infinity. Okay. Cool, cool, cool. Now, let's look at this. Oh my God. This is the worst. All right, you know what I could have done? All right, we're done with domain. Okay. Now, oh, wow. Okay. All right, domain, we think low to high. So now, same thing. Can I bound this arrow that's going towards infinity? No, I cannot. Okay, so what is this arrow going towards? What's my lowest point? Again, this is negative infinity for y and infinity for y. The range, I think, range is low to high. So now moving, and I think about my y now, not my x's. So now I'm scanning and I'm going low to high. Negative infinity to infinity. What is my lowest point? Well, if this arrow is going to the right and down towards infinity, that means that my lowest point is negative infinity. Whenever I write infinity, I write parentheses. And where is it ending? Again, I'm scanning low to high. What's my highest point? I can bound that point. There's no arrow going there in that direction. What is my highest point? When f of x is 4. You see that? And do I have a point at 4? Is it closed or open? Well, I have a closed point at 4 right here. And it's closed, so that means bracket. So the answer for range would be negative infinity to 4. Again, I'm scanning the graph low to high. Now, what else is it asking for? The problem is also asking for don't sorry. The problem is also asking for x-intercept and y-intercept. So I have to look at those values. All right, so y-intercept is any point that crosses my y-axis. So if I look at the graph, I look at my y-axis, which is this line right here, at x equals 0, and this one is my x-axis at y equals 0. So anything crossing, yes, the graph does cross my y-axis right here. All right, what is that point? That point is what? Well, for all y-intercepts, my x equals 0, always. That's how I know it's on this line. I'm not moving left to right of it. It has to stay on the line. So that's why anytime I write what my y-axis, my y-intercept, my x is always 0. X is equal to 0. What is my y? 1, 2, oh no. Oh wow, I messed this up. This is my y-axis. And this guy, I didn't read that correctly. This is actually my x-axis. Okay, I got a little confused myself. Okay, so now this is actually my x because this is 0. This is -1. So again, it's still 0. My x, what is my y at this point? It is 1, 2. Okay, so I only have one instance where the graph is crossing the y-axis or touching, and the point is at 0, 2. Now, what about my x-intercept? That is anything on the x-axis. Does my graph cross or touch the x-axis? Yes, it does, right here at this point. What point is that? That looks like, well, it's going by, my graph is going by 2, 4, 6, so it's going by 2s. So in between 0 and 2 looks to be 1. And just like my y-intercept, this is always 0, right? For my x-intercept, my y is 0. I don't have any height. It stays on the line. Okay? So this is my y int. Anything on the y-axis, this is my x-intercept. Anything on the x-axis. And then now, if the question asks for intercepts without specifying y or x, you would list both of these coordinate points, 0, 2 and 1, 0. If it asks specifically for the y-intercept, then you put 0, 2 as an ordered pair. Or if it specifically asks for x-intercept, then you put 1, 0 as an ordered pair. Okay, what else is the question asking for? Symmetry. Okay, I already answered it. There's no symmetry with respect to x, y, or the origin. Okay, the reason I say that the symmetry, well, what values are, let me look at the cheat sheet. Let me share that real quick. Okay, these are actually symmetric. This is symmetric with respect to the y-axis, because again, if I fold this as a hot dog, so long ways, this quadrant is this quarter right here. If I fold it over, it's going to give me this on this side over the y-axis. So symmetric over the y-axis, or respect to the y-axis, is hot dog. Same with this graph. This is respect to the x-axis. I messed up here. This is respect to the origin. Uh-oh. I have to edit this. Anything with symmetric with respect to the origin, that's wrong. Sorry, guys. Is again, if I grab a quadrant and I do hot dog and hamburger. So this one, if I flip over here, I get hot dog. And this, and I flip over here, I get hamburger. So it's two flips, y, and then over the x, that's how I get that mirror image. Same thing here. Y over the x, that's how I get this quadrant to match this quadrant. So that's symmetric to the origin. This is neither, not symmetric to anything. Okay, so now if I go back to the graph that I'm given for the homework, not the homework, the practice problem. If I take this side, this quadrant, and this quarter right here, and I flip it over the y, do I get this side at all? No, I don't. I'll draw it out. It would only be symmetric if I had this. But even then, I can't possibly have this because then I wouldn't have a function, right? I would have 2 points overlapping. Vertical line test, it would fail. But is this my original graph? No, it's not. So it's not symmetric to the y-axis. This is my original graph. Already, it's not symmetric to the y-axis. Now I'm going to see if it's symmetric to my origin. So symmetric to the origin means hot dog and hamburger. So I'm going to do hot dog first, then hamburger. I believe it'd be like this. Is this my original graph? That blue to red over here? No. Not symmetric to the origin. So this would be no symmetries at all. Not even close. Okay. So now, going back to the questions, it's asking for intervals that it's increasing and intervals that it is decreasing. Okay. So my graph looks like a U up and then a U down. That's the only way to draw a U is if I go up and down. Okay. So where is it increasing and where is it decreasing? So it appears, and then I always write increase, increase, and decrease. Scan. Oh, what the heck? Scan, like, domain. So just like we scan for the domain, that's how we scan increase and decrease. So we scan it in terms of the x values again. Okay. So from -3, it appears right here, to -2, because that's the peak, right? My graph is increasing. It's going up. So I would write that just like that. -3 to -2. Pretty straightforward. Now, where's it decreasing? Okay, well, it appears to be decreasing from -2 up to -2 to, we don't know. What is that? To, and what direction am I going? Towards infinity. Pretty straightforward. I just have to remember when I'm scanning from increase to decrease, I'm scanning like I scan the domain, I'm looking in terms of x. So when x is between -3 and -2, I'm increasing. And when x is -2 to infinity, I'm decreasing. And I think that's all it's asking for that graph. Well, let me share this one. There might be a few set more questions. Okay. Okay, now we have similar questions, but on top of the domain and range and increase and decrease, now they're asking for an absolute value, or if there's a minimum value. Okay, and I included this also in your cheat sheet. So first of all, let's look at the domain. Again, domain we scan left to right. What is my leftmost value here? -4. Where does it end? I want to say 3, but however, notice at 3, doesn't my graph go past 3 right here? It does a little bit. It's pretty narrow, but it's still slowly going towards what? Infinity. Again, I cannot bound an arrow in terms of the range and in terms of the domain. I can't bound it with a line. It's a big no-no. So if I have an arrow either going down, if I'm looking at range to the right or going down, I never put a line straight through it. So this graph is going from negative, the domain is going from -4 all the way to infinity because of the arrow. Okay? I cannot bound an arrow. Then at -4, is it open or closed circle? Open circle, that's why we have parentheses. And then infinity, we always write parentheses. So that one's kind of tricky. Because of it, you want to say 3, but really there's an arrow and it's going past 3 and it's going to go past several more numbers because it's going towards infinity. Now the range, I look low to high. So now I scan the graph from lowest point to the highest point. Again, I have an arrow. So this graph does not end at -5. I have an arrow. That's not a point. It's an arrow. That arrow is going towards infinity. What infinity? Negative infinity, because range goes -infinity to infinity. Domain goes -infinity to infinity. So it goes from -infinity to, what's my highest point? It appears to be 4. There's no arrows going this way, so it appears to be 4. So it goes from -infinity to 4, and then 4, is there a point there? Yes, there is, okay? There's no open circle. It's including 4. So I have a bracket. Now, what intervals is it increasing? Okay, well here it's decreasing my graph. I'm following the graph and I'm going down. Oh, now I'm going up and then I'm going down again. So where am I going up? Well, I'm going up like right here, I guess -2. That seems to be that point. And it's going up to when x is 2. Again, when I look at increase, decrease, I'm scanning left to right again, similar to domain. So I'm increasing from -2 to 2. Where am I decreasing? Everywhere else. -4 to -2, down. My graph is going down. From 2 to infinity, again, my graph is going down. In this case, there's 2 instances where I'm decreasing. Now, I would have a maximum value if I had this situation? Actually, you know what I'm gonna do? I'm gonna take a screenshot of this guy. Give me 1 second. Okay. So I wanna put it on. Images, upload, image, screenshot dose. Okay. All right, I just want to be able to draw over this. Okay. So now we're looking at max and min. And if we have, all right, so it's either going to say absolute or local. Okay, for both max and min. All right, so if I go back to my cheat sheet, which is, where is it? Right here. Oh, it's right here. So this is included in your cheat sheet. Same with the increase and decrease. Okay, what is the difference between a global or absolute? Okay, so I'll add that as well. And a local. Well, global means like the most, the absolute most. So this is still a max, I mean a min, but this is the biggest min we see. Okay, same here. This is still a max, kinda. It's a little hill, but this is the biggest hill we see. So it's like Mount Everest versus your local hiking spa. Same here. This is like a little valley. I mean, the biggest valley compared to the little valley. So local would be just like your local hiking. But if you wanted to do a big climb like Mount Everest or something extreme that's known globally or absolute, then it's going to be the biggest. Okay, so anything local maybe is not known globally. Make sense? So the biggest valley you see in the graph compared to the local valley. Same thing. The local max compared to the global or absolute max. Okay? So again, if I go back to the problem, the absolute, all right, this is the highest hill I see. And where is that hill at? Now, when I think of my absolute and my minimum, I'm going to think of the value. The value I'm going to write in terms of y. So what is my max value? Well, it's at x equals 2, but the value is 4. My minimum is at, and it's relative. Why is it relative? Notice I have an arrow here. What does that mean? That I have even lower values than negative. My graph is going to extend lower than -4. Make sense? Here, let me draw it. Because that graph is still going down. Again, but I look at the domain and range. Actually, it's actually going like this. Slowly, this way. So it is it's a local min because although this is a small hill, okay, it's still not my smallest value of the graph because my graph is extending even lower than -10 even. Okay, so it's just a little local guy. This is the highest. Okay, it would be a local max if my graph went like this. Make sense? So let's ignore everything in blue right now. Let's just pretend I didn't write anything down like that. That this was my graph instead. Ignore the blue. Just ignore it. And let's pretend this was my graph. Now, would this be a local max or a local min? Well, now it's my absolute or global lowest point right here at -4. What about this guy? This is the biggest hill, and my graph is not going past this hill. There's no arrow anymore going past it. So this is my absolute lowest point, and this would be my local lowest point. Again, when I look at max and min, I look at the y value. So my lowest point is at x equals -2, but however, the lowest point value is -4. The absolute is at -4. Absolute min is at -4. The local min is at x equals 4, but the local min is the value -2. The local max, it's local now because now I have an arrow and the graph extends past this point. Make sense? So this is a local max at 4. However, my graph extends past that point towards infinity. Okay, so that's the difference between the two. And again, looking at the domain and range, do we see why? Look here, the graph. Oh, I want to do that. We want to say it's from -4 to 3, but notice the graph goes past 3 still. Why? Because there's an arrow, and I can't bound the arrow. So when I say bound the arrow, I bound this point. That's my leftmost value. Can I bound this point? I can't because there's an arrow going through it. I can't. And it's going past it. The arrow means it's going to extend past that way. So that's why my domain is from -4 to 3. I mean, that's why my domain is from -4 to infinity and not 3. Same thing with the range. My arrow's still extending down to -infinity, and I'm able to bound it at 4 because there's no arrows going this way. Okay? So we do need to understand absolute max and min, and it's on my cheat sheet. Okay, so it's just like that little local valley compared to a big valley, or compared to an arrow. Okay, it's local if I have an arrow going in the same direction, just like I do here. Okay, so now the last thing you do need to know. Oh, we can see. Oh, we'll look at the intercepts. Okay, so this is asking specifically for the x-intercepts. There's 2 instances it crosses the graph, here and here. You want to say this one, but look, it's an open circle, so that means not inclusive. It crosses 0 and it crosses 3. If I told you to write as an ordered pair, it'd be 0, 0, and 3, 0. X-intercepts y 0, y-intercept x is 0. Okay. Again, left to right, right to left. All right, that's just touching up on essentially. Okay, so one of the questions on the exam as well is, when is f of x less than or equal to 0? So I wrote down under x-axis, f of x greater than or equal to 0, above x-axis. So this is saying, what is f of x again? My y. So when is my output less than or equal to 0? Well, my output is less than or equal to 0 at any value down here. What's a value less than y less than or equal to 0? -1. Is -1 less than or equal to 0? Yes. And is -1 an output or an input? It's an output for y. So when is my graph here to here? So now, same thing, looking at the intervals, but now instead of in terms of x, I'm looking in terms of y. It would be from, where is it underneath? Where is my graph underneath the x-axis? From -4 to 0. Then where else? from 3 to infinity. You see that? Where's my graph above the x-axis? F of x bigger than or equal to 0. Only here, only at this part, which is from 0 to 3. Yeah, there's only one question like that. But it's just saying, when is my graph above the x-axis? When is my graph under the x-axis? And I would still write it like increase and decrease. I'm looking at my x, but I'm just analyzing the output. Finally, piecewise functions. Okay, the only thing you need to understand for this is you need to understand which graph you're evaluating, which function you're evaluating for. So let's say I gave you a piecewise. This is a piecewise. What is a piecewise? It's just a function made up of different functions. Okay, it shouldn't scare you. All right. So normally we're used to just one function and one equation like this. Like f of x is equal to x squared plus 2. And that's it. It's only one function for that equation, just one. But I could graph that function and it'll look something like this, where it's just one graph, one line, and not 3 separate functions going on at the same time. But newsflash, I can have a piecewise function where I have a function made up of 3 functions, but they each have their own domain. That's the key part. So x plus 3, which is a line, the function is x plus 3. It's this guy. If x is less than -2. So notice at -2, this is the only instance I have x plus 3. Then from -2 to 3, I have this function. And then from x to greater than or equal to 3, I have x minus 4 function. So it's just telling me, okay, when x is a number, what function do I use? So find f of x when x is equal to -4. All right, so the steps I want to do with this is, okay, what x am I given? Okay, I'm given a -4. Which domain does it fit? Well, if x is equal to -4, is x, which is -4, bigger than or equal to 3? Is -4 bigger than or equal to 3? No, so I cannot use this function. Is -4 in between -2 and 3 at all? No, so I can't use this function. The only one I could plug it into to see what my output is, because it wants me to find my output, find f of x, find the output when x is -4, is this guy, because it's true that -4 is less than -2. So I plug in -4 for x. Now I'm able to find my output. But all I'm doing is I'm looking for where it makes sense to plug in my x. It only makes sense where my domain matches. So x is equal to -4. The only one it matches is the red. That's the only one I could plug it into. Otherwise, it's incorrect. Now find f of x, find the output when x is equal to 3. Okay, which domain does it fit? Is 3 less than or equal? Is 3 less than -2? No, so I can't plug it into the red function. It's either this one or this one, but which one do I know? Well, x is equal to 3. This is saying -2 is less than or equal to x less than 3. So it's not including 3 here. What about here? When x is equal to 3, if x is greater than or equal to 3. So I'm only looking at this function, x minus 4. And it wants me to solve for my output. So I'm evaluating at this function, x minus 4 for 3. That's why I have f of x is equal to x minus 4. That's the function I'm using with this domain. What's f of 3 now? I plug in 3 for x. So I have 3. Uh-oh, the math is wrong here. 3 minus 4, I should have wrote. Sorry. Uh-oh. 3 minus 4 is equal to -1. That would be my output. Yeah, that's an error. That's a typo. I was probably making that when I was a little bit sleepy. But again, I should plug in -4 for red function since it fits the domain. I should plug in 3 for green function since it fits its domain. And then I've just simply converted this piecewise function that looks like it's really hard, but really it's really easy because once I find the function that my x fits, what am I doing? I'm just evaluating for that x. And it becomes another simple evaluation problem. So that's it. That's essentially what the exam is about. Again, I'll have some cheat sheets provided for you guys. Your calculator will need to be test mode decimals if you're going to use it. Please download the application before the exam, and I wish you all good luck. Thank you.